Hey, it's been a cold week, Pittsburgh. Look at this snow this morning in downtown. I think this weather might have inspired some of our viewer questions this week. Yeah.
I know that that's not, the greatest to travel in, but look how pretty that is.
It is pretty, right?
Oh, it's gorgeous.
Yeah.
Meteorologist Mary Hours is here with all the answers. It's so good to have you back, Mary. It's been a very busy time for you.
It has been so busy. I mean, we went through December really not having much snow at all and a quiet winter last year. And then January just said, boom, we've got cold, we've got snow, and we're not done.
No, not by any stretch of the imagination. But I love these questions.
Yes.
Jeff is going to start us off today. He asks, is there any truth to the myth that it can be too cold to snow?
Okay, so it's never too cold to snow, but snow is less likely when it's cold.
Really?
So it all has to do with snow ratios and the amount of moisture in the atmosphere. So if you just look at, mainly we do it by a 10 to 1, 20 to 1, but if it's 34 degrees outside, you get that really, really wet snow. Yeah. And the colder it gets dry and it gets really light. So when it's 20 degrees below zero, I mean, if it's that cold, it's too cold to pretty much get a lot of snow because it is so dry and you need moisture for snow. Yeah. So if it's warmer and the temperatures are close to freezing, then the air will hold more moisture and that makes that really heavy wet snow. So like for example, Antarctica, it's the coldest place on Earth, but it doesn't get much snow because it's more like ice and it's more like a desert. I know.
Yeah,
so
it's the worst.
Yes. So just really cold air, I would say, just equals a less chance for snow.
Well, I like that though, because if it's really, really cold, you have to deal with that, but at least you don't have to deal with, if it's negative 10 degrees, the snow too.
I don't know. If it's going to be cold, I want someone to look at.
Yeah.
I need a payoff.
You'll get those really light, fluffy, but it's going to be that one that you're not going to be able to make a snowman out of. It's just going to be blowing around. It's really cold. Doesn't really stick. It's so cold type of deal.
Okay.
Yeah.
All right.
All right. Well, Janine, she wants to know, what are isobars?
Isobars. Okay, so isobars are the lines on a surface map, which we don't really show so much. It's more so what we meteorologists look at. So it's the line on a map, and it shows the area with the same air pressure. So think of air pressure is the weight of the air around us, right? So imagine you're drawing a line, and you're connecting all of the places that the air is pressing down. Okay, with the same strength. So those are the lines that are called isobars. And they help us meteorologists basically just figure out where it's windy, where it's calm, where storms might happen. The closer the lines are, the windier it is. And remember we talked about wind. Wind is basically two air masses just trying to get an equilibrium. Just find that equal spot. So it's like a battle, and they're just trying to become equal. So when the lines are closer together, it's a lot more windy. So.
I'm so glad that you're reading those graphs and I'm not.
Yeah.
I'm like, oh, look at that.
Trying to simplify it, you know.
We use it for a lot more circles. Like they're just kind of.
That's just one example. I mean, it can look so much different. I mean, there's tons of these all over the map, and you have your jet stream. So it's a lot. It's a lot for us. This is what we go to school to learn.
Yeah, there you go.
So I'm just trying. We're so glad you're here to break it down for us. Yeah, nailed it.
You're welcome.
I love this. Thanks, Mary.